Good morning, good afternoon, good evening. My name is Alvimar de Lucena Costa Jr. I am an aeronautical engineer, master in decision support in 2018, doctoral student in the post-graduation program in space sciences and technologies in ITA. My supervisor is Professor Michel Carmen Neira Belderheim. This theme has been discussed during the safety system classes of Professor Carlos Henrique Neto Larros, and I will present you our paper, Safety Analysis by Concurrent Teams, Use of Conflict Simulation under Drama Theory on a Social Experiment. One definition of safety analysis is that it is the process of 1. Identifying potential hazards that a system or its environment may present, and 2. Generate actions to mitigate these hazards. A system could represent a range of things, from the use of a simple recording device to a large entrepreneur endeavor, including areas like aviation, offshore operations, financial, scientific, and humanitarian endeavors. Under this aspect, most relevant enterprises on our days have multiple stakeholders, each one with its own agenda and objectives, which might prevent the fluid development of a safety analysis, or hide the most important target to be dealt with. This paper reports an experiment on the use of conflict simulation under drama theory to improve the resolution of conflicts between different organizations with different objectives and agendas, when they must deal with a comprehensive safety analysis done according to a system theoretic procedure like STEP. The method also would help find new insights from the messy situation before the confrontation itself, making an adequate way to prepare negotiation teams. The theory behind this paper involves two different areas of study: group decision and negotiation, and safety analysis. Drama theory is under the large area of group decision and negotiation, where there are 4 main research areas, and we are focusing on applied game theory, experiment, and social choice in this work. Drama theory is the relative preference branch of game theory, in opposition to the cardinal preferences branch. The cardinal preferences branch searches for scores. They are games with rules and points. Relative preferences incorporates models of utility functions that do not correspond to real values, opening the possibility of using such mixed strategies, preferences, and interests that would not be miscible, and its main representation on metagames. Metagame analysis splits in conflict analysis, which is based in the search and study of the stable points of negotiations and decision trees, and drama theory, which seeks in the dilemmas of confrontation, the understanding of non-rational behavior of the contenders of a negotiation. It is important to define that a conflict or confrontation here is broader than a fight or a skirmish. These areas deal with any conflict of interests. And what is drama theory? It is a problem structuring method, and using it can gather more information from the stakeholders and from the connections and interactions of all parts of a messy situation. When we compare drama theory with game analysis in DT, characters have individual beliefs where players, from a game, follow the rules of the game. Drama scenario is particular and customized, where a game scenario is perfectly defined. Game dilemmas resolution is based on quantification, score, victory, whereas resolution of drama dilemmas do not suppose a winner, but an agreement. We may also summarize drama theory as something that recalls a role-play game, but with a less restrictive book of rules. The game master also exists, as a facilitator or a mediator, but his role is intended only to prepare a customized scenario and characters. Drama theory simulates a confrontation to understand which dilemmas of confrontation or collaboration may occur during a negotiation. Drama theory may be performed by a role-play activity or under an analysis manner. It proposes an episodic model whereby situations unfold as the scheme shows. The episodic model begins at the scene setting, where an informationally closed environment is created. The next phase is the build-up, when the participants arrive on a common reference frame, what leads to either a confrontation or a collaboration. When a confrontation exists, an agreement must be created. When collaboration exists, an agreement must be sustained. Emotions are used to cope with disagreement, positive emotion to cement agreement. The episode may take both ways, from confrontation to collaboration and vice versa, depending on an agreement. When the agreement is settled, either created or sustained, the episode runs to a decision phase, where it's decided how the agreement should be implemented.
This decision to implementation may lead to a new episode, and the process may run again. Important: an agreement is not necessarily a peaceful one. The agreement may be "I will kill you." Probably, in this case, the process will lead to a new episode. DT uses a series of representations on each character's positions and how graphically show the progress of a negotiation. Cards and tableaus define the battlefield or what is discussed during the meeting. According to the revised drama theory, denominated Drama Theory 2, confrontation dilemmas were defined by Jim Bryant as persuasion, divided on by positioning and by threat, and rejection, also divided on by positioning and by threat. This way, identification of these feedbacks and systemic situations, looking for the confrontation dilemmas, are the base for the preparations and conduction of negotiation using drama theory. This drama theory process fits very well dealing with disputes that involve the hazard management analysis, a process under STAMP. STAMP, or System Theoretic Accident Model and Processes, is the name of the new accident causality model based on systems theory, which provides the theoretical foundation for STPA, System Theoretic Process Analysis. STPA focuses on the proposition that human activities, all human activities, can be represented by control schemes, and the controls of these schemes, when poorly executed or not executed, is what lead to some hazardous conditions or hazard. The process is organized in 4 phases: definition of purpose, modeling control structure, unsafe control action identification, and loss scenarios identification. What means? First, you identify what you're trying to avoid, the losses. Then, you get to identify which are the hazards of your system, the system-level hazards. A hazard is a system state or set of conditions that, together with a particular set of worst-case environmental conditions, will lead to a loss. Then, you'll model your system as a control structure, that is, a system model that is composed of feedback control loops. On third phase, based on the control structure defined, we look for the unsafe control actions that may lead to a hazard. On last fourth phase, the analyst should identify the loss scenarios, describing the causal factors that can lead to the unsafe control actions and to hazards. The analyst would consider why would the unsafe control action occur, or why they would be improperly executed. These areas of expertise were combined to determine a new way to look at a hazard assessment process that conveys more than one organization to understand and authorize take risks. The experiment used a PSM study class with 27 students through online meeting software. The class covered the topic of conflict resolution and drama theory, including DT2, and a quick reference to the STPA process. Finally, the group was briefed on what the experiment would look like. The students were divided into 2 groups, one representing an oil and gas contractor that would hire the service of an offshore air operator, the second group. The idea was that the air operator would focus on air safety issues, and the contractor would focus on commercial and operational issues. These objectives could end up on a conflict when the hazard prioritization had to be defined. This way, the teams had the interval week to discuss the first phase of STPA, identifying losses and hazards according to their characters, based on the values and objectives for each organization. The list of computed losses and hazards for the air operator was directly related to flight operations in its priority, having the contract fine payment as last priority, although present, like can be seen on its list of losses. On the other hand, as expected, from 4 losses identified by the oil contractor, only 1 was related to safety issues, the loss of human lives. All other are related to the regularity of the transportation. With the losses, hazards, and control structure prepared during the second period of class, the teams had 60 minutes to the scene-setting part of the episodical model of conflict, preparing for the negotiation. The objective of the experiment would be that both air operator and oil contractor agree on a priority list of hazards to be delivered to the Civil Aviation Authority to begin the operation of a shuttle helicopter line to a new offshore oil platform, much far away from the coast than the regular platforms available. Both sides had risks involved on the deal or no deal results. For example, the oil contractor is required by agreements to provide an air transportation service for the exchange of its employees' shifts at the oil rigs every 15 days, so they needed to settle the air service before beginning exploration of a new oil well. For the other side, the operator needs this new contract to keep alive once the aviation offshore market is passing through a down phase and their contracts are short. Both need the deal to be on, but both must demonstrate to the Civil Aviation Authority or to their shareholders how they will mitigate the most important hazards for the operation, both in safety and in regulatory and economic way. During scene setting, the identification of dilemmas was not formal, but its knowledge was considered determinant to prepare their arguments to keep their considered most important hazards on a high priority list. Both sides of contending dealt and changed their choice of hazards and priorities based on the ideas of possible dilemmas against the other side. This way, when the scene setting was ready, they had already simulated what kind of answer could come from their antagonists. So, they had ready options and plan Bs for their desired outcome. The time reserved for the build-up, confrontation or collaboration and decision phases was 60 minutes. Air operator took around 30 minutes presenting its hazards and justifying each priority on a build-up phase. Oil contractor assimilated and agreed to all information presented on a collaboration phase. By around 40 minutes of discussion, the priority position of 2 hazard points was questioned by the oil contractor, related to the regularity and the cost of operations, where he wanted them raised. Raising a hazard priority meant to concentrate mitigation efforts to its resolution before any other lower priority hazards. Operator showed hesitation moving up the regularity and cost hazards priority, and so moving down some helicopter safety operational hazards, arriving on a confrontation phase of the episode. This tension moment was an example of a persuasion dilemma by positioning for the operator and a rejection dilemma by threat for the contractor. The operator wanted to keep its position or wanted to persuade his opponent that his position was better, but the contractor explicitly opposed to the present priority list, rejecting the position offered and menacing the agreement with the threat of no deal. This way, they should find a way to compromise on the priorities order of hazards belonging to regularity and safety. The operator decided to play a card, where he will agree with the change if the contractor agrees to close the deal after that and finish the change. The 2 top list hazards were already related to safety anyway, one related to the structural integrity of helicopter operations, another related to helicopter operational control. With the confrontation part of the episode covered, at 46 minutes of discussion, the group passed to the decision and implementation part of the exercise, what took around 15 minutes. After that, the facilitator conducted a debriefing with the students, finalizing the experiment. The experiment showed that a composite process mixing hazard assessment analysis and conflict resolution process may conduct to a softer negotiation between 2 different stakeholders, minimizing time of discussion and hard-edge antagonizations. For a hazard assessment point of view, searching for an agreement instead of looking for a winner on a discussion contributes to improve the focus of the discussion: safety. Most endeavors being conducted these days involve multiple stakeholders and organizations, each one of them with different missions and objectives that may lead to different priority lists that could not cover all aspects of great enterprises. The protocol of a conflict resolution using drama theory allows both preparing teams for negotiation and to create insights of a problem to be solved by more than one stakeholders, brought to a negotiation table very often. Use of this protocol as part of the development of ASTPA contributes to safety, same way, allowing a softer discussion of different points of view and greater understanding of the control structure to be defined. The simulation using more than one stakeholder on an STPA showed that the tendency is that they will define several losses and hazards that could be very hard to cope. A suggestion for a future work could include the use of a multiple criteria decision analysis to define the priority of hazards, restraints, constraints, and mitigation actions to be proposed on a real-world application. The real world is often very complicated. We are trying to elaborate a model for it every day, but all models are wrong. Some are useful. Thank you for your time.